ఇక్కడ షేర్ చేసుకోవచ్చు. అదే ఎగ్నైట్ అయ్యేది ఉంది. లోడ్ అవుతుంది నెట్ ఇష్యూ ఉంది సార్ బాగా.
స్టూడెంట్స్ కూడా ఎవరు లేవు.
ఇప్పుడు వెళ్ళి చూడండి.
నెట్ ఇంకా నెట్ లేక షేర్ అవ్వట్లేదు.
ఇప్పుడు నన్ను అనుకుంటారండి, మిమ్మల్ని ఏమంటారు?
వచ్చింది ఇక్కడ
ఎక్కడ వచ్చింది? ఎక్కడ వచ్చింది? చెలేగు
ఒక 2 minutes అక్కడ జాయిన్ 10 members జాయిన్ అవ్వాలి. స్టార్ట్ చేస్తాను. స్లైడ్ ముందు నుంచి చెప్పండి సార్.
ఇది మళ్ళీ రిపీట్ చేయాలి.
యాక్చువల్లీ హ్యాడ్ నెట్ ఇష్యూ ఇంటర్నెట్ ఇష్యూ అని చెప్పండి సార్.
ఇది మళ్ళీ రిపీట్ చేస్తాను.
వన్ స్లైడ్ ముందు నుంచి చెప్పండి. యాక్చువల్లీ హ్యాడ్ స్మాల్ ఇంటర్నెట్ ఇష్యూ ఇవ్వాలి.
Okay. Everyone, can you please listen, Amma? Yes. Now it will come. Now, in order to work with your hackathon problems, yeah. Now, tomorrow, mostly on 7th of January, you have to work with Gemini models. Okay. In order to work with Gemini models, first of all, I will be discussing how to create API key. Now, I will be working in local computer, and all the Gemini models are available in remote machines. In order to access these Gemini models, first of all, you need to create API key. Okay, this API key. Yeah. Now, first of all, we will be communicating with API key. Through API key only, we can communicate with any kind of Gemini models. Now, step 1. Now I will discuss about how to create Gemini key. How to create Gemini API key. Yeah. Then second step, we will be discussing how to install software. How to install software. That communication between local computer and remote server. Then we are eligible to send a request. Then we will be getting responses from LLMs. Okay. Yeah. Now, once we create a API key, then we are eligible to send a prompt from local computer to Gemini LLMs. Then we will be getting responses from LLMs. Okay. Now we will discuss about how to create a prompt, how to create response in few minutes. So first of all, I will be starting how to create API key. In order to create API key, first of all, we should go to this link. Okay. So everyone should go to ai.google.dev. ai.google.dev. First of all, I'll give you the link. In the Google, you type get API key Google AI Studio. Then you will be navigated to this link. Whenever we navigated to this link, simply here is a button called create or view Gemini key. Click on here. Yeah. First time, if you want to create API key, you are going to click here. Whenever you click API key, it will ask you to select a project. Now I already selected my project. Okay, now then create API key. That's it. Now you can see your API key. Now using this API key, you can start programming. Okay, everyone is okay, Nama? Okay, just simply copy this API key, copy and store in your local machine. Okay, now we'll use it in our programming. Yeah, save it. Okay, and save it as API key. Yeah. Now we are eligible to start programming. Now, once the API key is created, then slowly we will go to, yeah. Once API key is created, then the second step is we need to install a software. Second step is need to install a software. Install a software. That is, you must install pip install Google-generative AI. Okay, now. So the first step is create API key. Once after creation of API key, the next step is we need to install a software that is called as Google-generative AI. Okay, now. And the third step is once the software has been installed in your machine, then you must import, okay, Gemini API. Now it will be done. Import Google.generative AI. Now, in order to access this generative AI, we can use alias name called as Gen AI. Okay, now import Gemini AI. It will be done by using import Google.generative AI. Now, if we want to give any short name, we can give by using alias name. Okay, alias Gen AI. I hope till now okay for all of you. Now, once we imported the software, then second step is we need to configure. Okay, now whatever the key we have created, that key has to be configured here by using genai.configure. Now, because it is free, you can configure publicly. Now, whatever the key is there, copy the key. After the program, I will be sharing all the programs to you. Okay, is it okay? Now, whatever the key we created, that key has been configured in the Gen AI. Okay, now kindly respond, Amma. So the first step is creation of API key. Second step is installation of software. Third step is importing Google.generative AI. And fourth step is configuring our generative AI key with this Gen AI. Then once configuration is completed, then the next step is, now let me introduce what are the models. Now today Gemini supports several kinds of models. Okay, out of them I will be using Gemini-2.5 Flash to do our programming. Now what are the models are there? If you want to know, I will be writing a small logic here. Yeah. So if you want to know whatever the models are there in the Gemini, you must use this one. Okay. GenAI.list of models. Earlier in GenAI 1.0, we have very few models, but once we reach 1.5, 2.0 and 2.5, where are 30 to 50 models are there. Today, I will be using the model called Gemini-2.5 Flash to do our today's programming. Okay, I'm using this model. So first of all, let us discuss what are the features of Gemini 2.5. Gemini 2.5 is a Google's DeepMind 2.5 family model and which is designed for fast and efficient inference and which also provides optimized high throughput and low latency tasks. Using this model, we can create applications such as chatbots, voice assistants, real-time query answerings, and RAG pipelines. Today, I will be demonstrating RAG pipeline. Then we can create a lightweight reasoning tasks. Okay, now once we connected our Gemini API key, then we are eligible to call a model. Now let me call the model. Generative AI dot. There is a function called as generative model. Out of 30 to 50 models, whatever the models are available, now I'm activating Gemini 2.5 Flash. Yes. Now we are eligible. Okay. Let me draw a small diagram. Yeah. Now our program is ready. This is our local program, Gemini program. And we are ready with our Gemini model, Gemini 2.5 Flash. And we already configured with API key. Yeah. Now we are eligible to send a prompt. Okay. We are eligible to send a prompt. Now I will be creating a prompt such as what is the AI in simple. What is the AI simply defined? Okay. Now I am sending my prompt using a function called as model. Model dot this model dot. There is a function called as generate content. Using this function, I will be sending the prompt. Now let us test the prompt. Yeah. See here. Yeah. Now I'm printing my response. What is the response we are getting? Generate content response. Now, if you want to extract the text from the response, there is a property called as text. Okay. Look at here. Everyone. Yeah. Now it has been given a small definition of AI. Okay. Now, kindly respond, Amma. AI is a machine designed to mimic human intelligence. I hope everyone is okay. Now, I have discussed about how to create a prompt and how to send a prompt to LLM and how to get response. I hope everyone is okay, Nama? Okay. Now, with your permission, I wanted to discuss about another very important task. Yeah. Now, once we created a local computer, my program will be here. And this is our LLM model, Gemini Flash LLM model. 2.5 Flash. Then, now we are sending a prompt. We are sending a prompt. Now we are getting response. Now, each and every student must remember two things. First of all, now whatever the responses we are coming, okay, now it is always huge amount of data. So, in order to control these responses, we are going to use a parameter called as a configuration parameters. Okay. Configuration parameters are used to control the LLM response. Used to control the LLM response. Such as temperature. Then, now temperature in the sense, there will be two kinds. High temperature and low temperature. High temperature means it will be 1.0. Low temperature means it will be 0.0. Okay, now whenever we give the temperature high 1.0, always we are going to get creative responses from LLM. Okay, now whenever we give temperature 1.0, always LLMs uses creative responses. Whenever the temperature is low, means 0.0 always it creates own responses. Yeah. Now, after this temperature, we can also control maximum underscore output underscore tokens. Yeah. How many tokens has to be released from Gemini Flash model to our program? We can control them. Then third one is top K and top P. Okay. Using these configuration parameters, we can configure whatever the data which is coming from Gemini LLM to our local computer, we can configure them. Next one is prompt. A prompt is a piece of information. A prompt is a piece of information which we are sending from local computer to AI machine, AI system. Yeah. Now, let me discuss and demonstrate in detail about what are configuration parameters and yeah. So look at here. Yeah. Now we have various configuration parameters such as first one is maximum underscore output underscore tokens. Okay, now which is going to this parameter limits how many tokens a model can generate. Then second kind of parameter is called as temperature. Temperature controls the entire creating response. Now temperature controls how random or creative the model is. Where whenever we give high temperature, which always creates random and diversity responses. Whenever you are going to give low temperature, always you are going, LLM will get predictable and deterministic answers we will get. Then, other than them, we also have two more parameters called top K and top P. Now, the top K represents a number of the most probable tokens to choose. Top P will discuss about cumulative probability threshold for the candidate tokens. These are the four configuration parameters which will be controlled. Whatever responses which are coming from LLM to our local computer. Then, now let us focus more on prompts. So let us discuss about what is a prompt. Then we'll go to our topic. Yeah. Yeah. Now let me discuss in detail about what is a prompt. Yeah. Now let me define what is a prompt. Prompt is a prompt is an AI is a piece of information which is given to any artificial intelligence models to produce specific responses. Whereas prompt engineering is a process of asking right questions to get best output from AI model. Okay. Now it allows right interaction with the model using simple English language. Now tomorrow in the hackathon, you have to provide beautiful prompts to extract information from various domains. Now, few minutes I will discuss about kinds of prompts. So first of all, I will be discussing Now, first kind of prompt is called as instructional prompt. In the hackathon, you may work with various kinds of domains such as banking or insurance or retail or healthcare or agricultural, where always we will be providing instructional prompt. Means tell the model to do something clearly. Now, an instructional prompt is a prompt where we are telling to the model exactly what task to be using to direct the command, where we are not providing any examples to the LLMs. We are going to clear instructions only. Now, let us ask that we have to say you are a researcher. Yeah, you are a data analyst. Yeah, now you are a data scientist. Like this, we need to provide a clear-cut instruction to the LLM. Based on that, this will become role for LLM. Now, in this example, I will be discussing a small example. Yeah, I will be saying to my machine that summarize the following paragraph. Means I am instructing my LLM that kindly use data summarization. Now I will be taking a small paragraph from newspaper article and it is giving summary of the information. Okay, now this is called as a instructional prompt. Then second one is called as a few short prompts. Sometimes we need to give some extra information to the prompt. Few short prompts provides examples to guide the model, where the model is given few examples of input and output pairs in the prompt. Another thing is one shot prompt. One shot prompt is a special case of few shot prompt where we will be providing only one example. Based on that, LLM will give understand. Okay. Yeah. Now, in this example, what we are doing? Convert the sentence into past tense. Now, here I have given example. She goes to school. That means present tense. Past tense is she went to school. Now, here we have given one example. This is called as a one shot prompt. Okay, now here I am asking the question. He eats an apple. That means the question has been converted into now he eats an apple is a present tense. So the LLM has converted the answer as he eats an apple, where we are going to provide one example. Whereas in zero shot prompt, we are just asking the question directly without providing any examples. Here I told that translate how are you in Hindi. LLM is converting the data into aap kaise hai. Are you getting me? Here, aap kaise hai. That means in zero shot prompt, we don't give any examples. In one shot prompt, we will give one example to the LLM, and in few shot prompt, we will give 2 to 3 or 2 to 10 examples to the LLM. Okay, now can you respond, Amma? Yeah. Now this is an introduction. So with this, so shall I go to my current class? Yeah. I hope everyone is okay, Nama? Everyone understood how to create API key? Create API key. Then second one is how to install software. Then third one is how to import libraries. Then fourth one is how to send a prompt. And fifth one is how to get responses from LLMs. Okay. Once we completed this, so shall I continue my today's topic? And in the previous video, we have shared it to you where we have discussed about all the process manually. Okay. Now, with your permission, I will be starting what is the purpose of RAG. Why this RAG is useful in implementing of applications. Okay, shall we go? Yeah. First few minutes, I will discuss about the introduction part, then I'll go to the syllabus. Everyone, can you please respond, Amma? Yeah. I already discussed about this logic. Okay. How to create a Gemini model. Okay. How to import the specific model, then how to create a prompt and how to get the response. Okay, now. Yeah. So today I will be discussing a beautiful and most important topic is called as RAG. I will be discussing why RAG first of all. Now earlier what we have done, this is our LLM, our Gemini LLM. Yeah. Now we are sending a prompt. We are sending a prompt. Yeah. Now LLM will be giving responses. Yeah. Now, whatever the responses we are getting, sometimes we will get hallucinations. Because if we don't support any proper context, sometimes LLMs will give wrong answers. Those wrong answers are called as hallucinations. In order to reduce these hallucinations, we are going to use a beautiful framework called as RAG, stands for Retrieval, Augmentation, and Generation. Yeah. Now, I will be starting the topic. Yeah. Now, RAG stands for Retrieval Augment Generation. It is a powerful technique where we are combining two topics. One is retrieval mechanism. We are combining with text generation mechanism. Once again, I'm repeating, RAG contains two steps where we are combining retrieval from external data sources. The first step is retrieval from external data sources. I will discuss one by one. External data sources. Then next step is called as text generation. This text generation will be done from LLMs. Okay, now it is useful when you want an LLM such as our Llama, GPT, or Gemini models. Yeah, to answer questions with our own data. If LLM wants to answer for our documents, our own documents, maybe our notepad documents, our PDF documents, or our web documents. Now we need to train the RAG models. Now, why we should go to RAG? Because RAG keeps LLM responses grounded facts, means always it gives right information for us. Second one is which reduces hallucinations, and we can keep our own data as private with us. Now, using RAG, we can get answers to any question, any document, any domain. In this regard, I wanted to discuss about the architecture of RAG. So shall I take? Yeah. Now, everyone please listen. First of all, let me discuss about RAG architecture. RAG architecture. First, let me explain steps, then I'll go to the diagram. The first step is called as knowledge base. Knowledge base in the sense, we will be using all kinds of web documents or PDF documents or notepad documents. Yeah, later I will go for real-time case studies that can be used in the hackathon by you. Okay. Now, the second step is called as parsing. Yeah, the meaning of parsing means extracting text from large databases. Large databases. Yeah. Third one is chunking. Third step in RAG is called as chunking. Chunking means dividing large documents into small documents. Why we should do this chunking? Because every LLM has its own context width. Yeah. Fourth step is called as embedding. Embedding means converting this text into numerical vectors. Converting this text into numerical vectors. Yeah. Now, the fifth step is called as whatever the numerical vectors are there, they will be stored in the vector databases. Vector databases. Store and index these numerical vectors in the vector databases. Yeah. Now, for this today, I will be introducing a tool called FAISS. FAISS is a vector database which is developed by Meta. It is a free of cost. Okay, now sixth step. Now we are going to take a query from user. Yeah. ఇప్పటి వరకు LLM will not come into the picture. Now the query will also be doing embedding. And this query will be given to this vector database. Now it is going to search for relevant documents. Search for relevant documents. Now, whatever the output we are getting is called as retrieval. Yeah. In RAG, R stands for retrieval. Whatever we discuss it. Now, here, these retrieval documents are called as context for the LLM. Okay, now. Everyone, can you please respond now? 6 steps. The first one is knowledge base. In tomorrow's hackathon, we will be giving problems from various domains where you should collect the domain documents from either Google or any websites. Then you should convert the data into either notepad documents or PDF documents. Okay, now then that will be called as knowledge base. Then second step is called as parsing, means extracting. These are the large databases. So we need to extract text from the large databases is called as parsing. Third step is called as chunking. Dividing the large documents into small document is called as chunking. Fifth step is called as embedding, means converting the text documents into numerical vectors. Fifth step is called as vector store, where by using FAISS, ChromaDB, Pinecone, we are going to store these numerical vectors into the vector database. And sixth step is called as query. Query will also be doing embedding, and this query will be given for vector store. Then we are going to search for relevant documents. Syntactic and semantic documents will be searched within the vector store. Now, whatever the documents we are doing, this is called as retrieval. So here we will be retrieving context. Now let me go to the diagram carefully. Yeah. Is it okay? Now, first of all, this is called as knowledge base, KB, knowledge base. Second step is called as parsing. Okay, this is nothing but parsed documents. Third step is called as chunking, dividing the large documents into small chunks. Once after doing chunking, then we should do embedding, means converting the text into numerical vectors. Converting text into numerical vectors. Yeah. So once after completion of the conversion of the data into numerical vectors, then sixth step is called as indexing in the vector store. Okay, now. So up to here, whatever I discussed this one. Then next step is called as we need to take query. Need to take query from user, embedding the query and search this query in the vector store. Then whatever retrieval is called as R. Now, whatever the documents we are retrieving, this is called as relevant documents. Okay, now for this relevant documents, if you provide a prompt plus retrieval documents is called as augmentation. Okay, now clear for everyone? Yeah. Now, once we got the prompt, send the prompt to LLM and LLMs will do generation. So this is called as RAG. Okay, RAG. Everyone, can you respond to me? Yeah. The first one is document loading. Second one is chunking. Third one is embedding. Fourth one is vector store. Fifth one is retrieving relevant documents. And sixth one is LLM generation. So this is about the architecture of RAG. In this architecture of RAG, we will be having various components: loaders, loading the documents; splitters, dividing the data, small documents; embedder, vector store, retrieval, and LLM generator. This is called as architecture of RAG. Now, I wanted to implement a beautiful real-time case study. Now that will be useful for the hackathon. Yeah. Can you respond? The screen is okay for all of you? All the people, can you please respond to me? Now I will be implementing how a program will be implemented with RAG with FAISS. Can I go? Yeah. In this example, I will be implementing RAG, retrieval augmentation generation with a vector database called as FAISS. FAISS is a vector database which is provided by Meta. Okay, now shall we go? Yeah. Now, in order to implement the program, first of all, we need to import the software, FAISS. Okay. We need to install this library. Okay. Now, the first library we need to install is called as FAISS CPU. Okay. Now, then second one, we know about it. Import Google.generative AI as GenAI. This everyone knows about it. This is the software used to communicate from local computer to remote LLM. And third one is sentence transformer. This sentence transformer class is used for embedding purpose. Okay. Yeah. Now, if we want to implement any kind of RAG application, what are the requirements we need? We need some knowledge base, some documents. Then second one is we need a embedding document, embedder. Then we need a FAISS object. Using this embedder, now let us convert the documents into embedding one by one, step by step. So I hope everyone is okay. Yeah. First of all, FAISS is used for vector store. Then pickle I will discuss in 2 minutes. And second one is to communicate from local machine to remote machine. We will use import google.generative.ai, then sentence transformer, which will be used for embedding purpose. So now sentence transformer will be used to convert numerical vectors, and FAISS is a user for similarity search library for indexing and searching. Then Google Generative AI is to interact with the Gemini models. Then next one, we are configuring with our key. So first of all, let me open this, then start configuration. Okay. Now we are configuring to Gemini 2.5 Flash. Okay. Once the configuration has been completed, just we will wait for another 5 seconds to run this cell. Yeah. In the meantime, we'll start discussion of what is sentence transformer. Okay. Now, in the sentence transformer, I will be using an LLM called Almini LM L6V2. Okay. Almini LM L6V2, which is a small LLM. Yeah. Look at here, ma. Almini LM V6V2 is a lightweight, fast model for user for semantic search. Now, this is used to create embedder object. Yes, we got the embedder object right now. See here. Now, Almini L6V2, it is a pre-trained model that converts text into numerical vectors. Yes, now embedding has been done. Yes, this is an embedded object. Then, yeah. Now, what is Almini L6V2? It is a pre-trained sentence embedding model which uses a sentence transformer library where the model converts text into numerical vectors. This is called as embedding models. Is it okay for all of you? Now, why we are using Almini L6V2? Because it is a lightweight and fast, always which provides good accuracy for the questions, and which is very easy to use. Now, I will be using 5 documents. Document 1, the capital of France is Paris. Then the Great Wall of China, built several centuries back. Python is a popular programming language used for AI and data science application. Mount test. Now I have taken 5 documents. Okay. Yeah. Now what I am doing, I will be converting our knowledge base into embedder. Look at here, ma. We already created embedder object with us. Yeah, we already created embedder object with us. Now I need to pass this embedder object. It has a function called as encode, which has a function called as encode. Then we are passing all these documents to this object. Now see what happens. Yeah. So every sentence will be created into numerical vectors. It is called as a numerical vector. Okay. So till now what we have done, whatever the text documents we have, these text documents are converted into numerical vectors. Okay, numerical vectors using a pre-trained model called as Gemini LM L6V2. Okay, this is a model name. I hope it is okay. Yeah. Now here I have taken 5 documents. This is document 1, document 2, document 3, document 4, document 5. But now every document will be 384 vector. Why it is 384 vector? Because Gemini L6V2 converts the numerical vectors with a length 384 only. Okay, now I will show you the length of this vector. See here. Yeah. Now, is it okay? 5 documents and 384 means if you want to increase 384 to 786, there is other mechanism. Using Hugging Face also we can do this. Okay. Now, here converting each document into vector embedding. Then, now here we have 2 shapes. Everyone, can you please look at here? Now, shape of 0 means number of documents. Shape of 1 means size of each vector. Now, I wanted to show you embeddings, not shape of 1. So, it is giving 384 vector. Shape of 0 means it will give me 5 documents. Okay, now, I hope everyone understood. Shape of 0 gives number of documents and shape of 1 gives each and every column vector size. By default, Gemini LM L6V2 provides 384 vectors. Okay, now, can you respond, Amma? Yeah. Once embedding is completed, then we are going to use FAISS. Yeah, FAISS will be used for vector store. Yeah. Now, here what we are doing, whatever the documents, numerical vectors are there, whatever the numerical vectors are there, this numerical vectors we are storing in the FAISS index. Is it okay? Now, look at here what I am doing. First of all, I created an index object and I'm adding embeddings into that. Okay. Yeah. Now here what we have done, which is initializing FAISS index, where we are using index mechanism called as L2 distance. L2 distance and Euclidean distance. Okay, now where we have added whatever the documents are there, we have added onto the embedding. Is it okay? Now, where L2 distance is nothing but Euclidean distance. Yeah. Now, my model is ready. Now, initially I said that there is a library called as Pickle. Pickle is a library used to store the model and load the model. Now, whatever the model we created, we will be stored in Pickle. Look at here, everyone. Yeah. Now, I am writing. Pickle has a function called as dump. Whatever documents we have, those documents we are storing in a file with PKL. PKL is an extension. So we have written the file. Yes. Then what we are doing till now, whatever we have done is called as injecting the data. Then the second step is called as retrieving. Now let us go for a query first of all. Yes. Now what kind of query I am asking? What is capital of France? I asked this question. What is the capital of France? Now I am calling a question, rack query. Now, whenever we call rack query function, now directly we are going to call a function called as rack query. Yes. What is my query? What is the capital of France? Okay. Here, my question is, what is the capital of France? And I am asking top 2 documents from the vector store. Okay, now in order to get this top 2 documents, we are internally calling one more function called as retrieve. Okay, now here we are calling a function called as retrieve by sending a query and top 2 documents. Okay, yeah. Yeah. Now, here, what is the capital of France? I want top 2 documents. Then what I am doing here, very, very important job, this one. Okay, now query also, what if we said query also doing embedding? Yeah. Now this is called as query vector. Now what to do? We have a vector store and we have a query. Now this query has to be matched in the vector store by using search function. Look at here, index.search. దేని సెర్చ్ చేస్తున్నాం మనం? వీఆర్ సెర్చింగ్ ద క్వరీ వెక్టర్ ఫర్ టాప్ 10 డాక్యుమెంట్స్. ఓకేనా? నౌ సెర్చ్ ఫంక్షన్ ఆల్వేస్ రిటర్న్స్ two elements. One is distance and another one is index parameters. Okay, now always whenever we send our query to vector store, always the search function will return two documents. One is distances, another one is indexes. Now let me run one by one. Okay, I'll show you. Yeah. So let me run one by one. Yeah. Next, I need to run this. Indexing has been done. Then open the data and retrieve the documents. Now let us call this query. Yeah. Now in this query, I will be sending a prompt. Answer the question using the following context. If the context is not enough, say you don't know. This is called as prompt. Now what is this context here? Now whatever the documents we are giving retrieving, retrieve function returns retrieved documents. So how to get this retrieved documents? Everyone. Now this retrieved documents will be joined to context. So I will be whatever the documents which were coming, they will be stored in the context. See here. Now I'm sending this prompt plus context plus query. This is called as augmentation. Okay, now whatever the prompt we created, this prompt we are sending to generate content function. Now we will be getting responses. See here. Yeah. Now whenever I run this query, what is the query I have given? What is the capital of France? So I am getting index numbers. Okay. Now index numbers I got 0.24 for one document, 1.7 for another document. So the answer is the capital of France is Paris. Now how to understand these 2 points? Yeah. Euclidean distance always having the distance between 0 to 1. Here for my query, the distance is 0.24. This is very closest to the query. 1.7 is not closest. So the answer for this question, capital of France is Paris. Now I'll give one more question. See here. What is the Taj Mahal? Where is Taj Mahal located? Yeah. The Taj Mahal located at Agra. Now for my questions, my first query has given 0.48 distance and second query has given 1.52. So Mount Everest is not the answer. So the answer is the Taj Mahal is located at Agra. Third question, what I am asking, which is the highest mountain? Yeah, see here. Yeah, the highest mountain is Mount Everest. Is it okay? This is the beauty of RAG. All the people, can you respond, Amma? And any questions till now? If you have any questions, then another very, very important task is this one here. We need to spend 5 minutes on here. Yeah, this one. Now here, whenever we are searching the query in the vector store, we are getting distances and we are getting indexes. Okay, now first of all, we are going to extract one index. Yeah, index number will be given for document. Now whenever you are going to provide an index number, and we will be retrieving the documents. Okay, the documents will be printed to the screen. This is what is basically RAG in the industry. Okay, in tomorrow's, yeah, now 2 minutes I will be speak regarding tomorrow's problems. So in 7th January hackathon, at GPREC, we will be giving 50 real-time problems. Where a student can use generative AI with LLMs with various prompts. Yeah. Now you need to create a Streamlit library. Streamlit application. Plus today I'm introducing RAG, retrieval augmentation generation. If you use RAG in the project, that will be added advantage for getting price. Okay, now can you respond, Amma? Now I will wait for 2 minutes. Any questions from anyone? Any questions from anyone? Then I'll go for Same program with RAG I will teach with PDF documents and Notepad documents. Is it okay? Now, same program that now in order to discuss this project, I will be taking two files. So I will be taking two files. One is lifecycle.pdf. Second one is lifecycle.text file. Now, in this program, we will be discussing how to extract the data from PDF file as well as text file. Shall we go? Yeah. First of all, I will be sharing this to you here. Life cycle. Yeah. In this document, I have taken 8 life cycle steps, starting from problem definition, data collection, data preparation, model selection, model training, model evaluation, model optimization, and model deployment. So 8 life cycle steps. Plus, I am also giving 8 domains applications in the document. Is it okay? This is a PDF document. Then I will be considering another document. Yeah. Now I will be taking another document. Just give me 1 minute. So I will be collecting this file, my lifecycle.text file. Yeah. Now we will be working with one PDF file, one text file in the directory. So in real-time applications, you may work with 5 documents and 10 documents. Now in this current application, everyone, can you please look at here, ma? Yeah. So first of all, I am importing all the libraries. Yeah. Now, because today I wanted to access the data from PDF file, we have to use a library called as a PDF reader. Okay. Now, in order to work with PDF reader, you must import a software called as a PyPDF2. Remaining things are same. Okay. Now, as previous program, shall we go? Yeah. Now I will be configuring with my Gemini. Then I will be using sentence transformer with Almini L6v2 and this function load underscore text underscore file will be used to access the data from text file. This is normal core Python file IO. Okay, na? Load underscore text underscore file is a function used to access the data from the file. Then if we want to read the data from PDF file, first of all, you need to create a PDF reader object. Then whatever the number of pages are there, you need to access one by one page and you need to extract the text. This function is used to access the data from PDF file. Okay, for all of you, this function is used to access the data from a file and this function is used to access the data from PDF file. Okay, now because in this program, I'm using both one notepad file and text file. See here, notepad file. Yeah. In this notepad file, I have taken 8 lifecycle steps. Is it okay? Now, let us work with RAG application. Yeah. Now, this logic is useful for chunking the logic. Now, why the meaning of chunking? And why the purpose is chunking? Chunking. The basic purpose of chunking is dividing large documents into small documents. Now, why this chunking? To maintain semantic similarity. Semantic similarity. Now, I will spend 2 minutes. For example, in this, the chunk size is 0 to 300 documents. For example, if the chunk size is 0 to 300, if my document contains 1000 characters, okay, now. So, my first chunk is 0 to 299. Then, to take another chunk, we are going to overlap 50 bytes. So, means 299 minus 50, 249. Next chunk starts from 249. 249 to 500. So, next will be 349, 449, 549. Now, this overlapping is very much required. Why? Because whenever I give a question, my question has to get semantic similarity. So, this chunk function is used to divide the large documents into small chunks. While doing chunks, we have to go for overlapping. If we go for overlapping chunks, the data will maintain semantic relationship between the documents. Okay, for all of you? Yeah. Now, this step, now let me go one by one. Yeah. First of all, this function is called as load the data from Notepad documents. This function is used for loading the data from PDF file. Then chunk underscore text is a function from used to divide the large data into small chunks. Okay now. Then now here we are building index. How we are building index? Because I have to capture, please. Now, in order to capture dot text files, I'm searching for the file name ends with dot text file. Then I'm calling load underscore text underscore file function. Then it will go here. It will read the data from file. Second one, if the file name ends with PDF, I'm calling a function called as load underscore PDF underscore file. It will go here. It will extract the data from PDF file. Okay, now kindly respond, Amma. Now here, first of all, I'm extracting the data. So whatever the data we are extracting, the chunks will be stored in a list object called as chunks. We are adding all the chunks into the list object chunks. Okay, now whatever chunks are there, those chunks will be doing embedding. Okay, now remaining logic is same. Dimensions of 1 and right index. Then slowly here in this case, I wanted to retrieve what is my query here? Yeah, here I asked my query domains in machine learning. Okay, now so whatever question we have, then I'm asking top 3 documents, query and top 3 documents. Then we know this logic. We are going to call a function called as retrieve, where we are sending a query and how many documents if we want? Top 3 documents. Okay, now for that we are sending a prompt. Answer the question using only the following context. If the context is not enough, say we don't know. Okay, kindly respond. Now whatever the context we extracted from this retrieve documents, that will be sending this prompt to model.generate underscore content. Okay, now we will be getting response. Whatever the responses we are getting, yeah, I will be printing here. Is it okay, Nama? I will be printing document here. So domains in machine learning. So whatever the domains I asked, it is extracted correctly, like healthcare domain, finance domain, and so on. And here I asked one more question. What are the life cycle steps in machine learning? So it went to the file. It is extracting only the relevant documents. This is the beauty of RAG. Mostly we from VCube Software Solutions, we expect all the team members to work with Gemini LLM model, to work with proper prompts and proper RAG application to extract relevant information for the queries. Okay, now if you have any questions, I will be happy to respond to your queries. Now I will be waiting for 10 to 12 minutes to have any of your questions. You can ask in the YouTube channel and my team will share to me. I will answer all your questions. Any questions, please? Yeah. Any questions if you have, please ask me. I will be happy to respond. Please tell me, Amma. Yeah, tell me. Huh?
Muted.
Yeah, please. After giving the problem statement, you will be having around 4 to 5 hours time. Okay. Then we will take a 2-hour evaluation. Every team will be personally evaluated by the industry people. And the winners will be awarded with good cash prizes and medals by VCube Software Solutions. Any technical, non-technical question, definitely I will answer, Amma, please. There are two stages of evaluation. First stage is we expect everyone should prepare a small application where my previous faculty has discussed about SQLite application. If any student who is good enough with the implementation of RABBug application, he will be get added advantage. Okay. Yeah. Problem statement, we already prepared 50 problem statements, Amma. See here, we already prepared 50 problem statements that cannot be shown to you. Okay. This is the problem statement. Domains. Okay. Problem statements will be shared on the day of hackathon. Okay. Now don't provoke me to open the problem statements. Okay. Now I will be sharing these two programs, Amma. No issue, no issue. You can explain in Telugu or English, doesn't matter. But your project should understandable to us. That's it, Amma. Medium is not at all matter for us. Okay. Yeah. Any more questions? So shall we stop the session, Amma? Thank you very much for all of you for joining. And I hope every team will excel on the hackathon day. I wish and welcome you all. Thank you very much for joining the session. Shall we stop?